Hello, and welcome to this explainer. Today we're diving into some truly fascinating developments in computer science. But rather than just looking at a dry list of disconnected technologies, we're going to use a central metaphor, the digital organism. You see, modern tech trends, they don't really act like isolated tools sitting on a desk anymore. Supported by massive computing infrastructures, they are rapidly evolving to act like interconnected parts of a living, breathing system. So, every time you pick up your smartphone or search the web, you're literally interacting with this organism. Today, we're going to break down exactly how this digital entity thinks, feels, moves, and communicates. To set the stage here, consider this brilliant quote from computer science pioneer Edsger Dijkstra. Computer science is no more about computers than astronomy is about telescopes. I mean, wow. That is such a profound way to look at the world around us. This explainer isn't just about the hardware, the metal, the glass, the microchips. It's really about how these emerging technologies fundamentally shift our interaction with the digital world. The computer is just the instrument, right? What we're really studying is the vast universe of data and connectivity it reveals to us.
Okay, let's dive into this. Here is our anatomical chart for the explainer. First, the era of emerging trends. Second, the brain, which is artificial intelligence. Third, the senses, exploring immersive experiences. Fourth, the body, looking at advanced robotics. Fifth, the lifeblood, which is big data. And finally, number 6, the nervous system, or the IoT.
Section 1. The Era of Emerging Trends.
To really grasp the rapid developments happening all around us, we have to look past the fleeting fads. We're focusing on the foundational, state-of-the-art technologies that are actually prospering and will dictate the future of our digital economy. These aren't just clever gadgets. They are the fundamental building blocks reshaping how digital societies operate and interact at a massive scale.
Section 2. The Brain. Artificial Intelligence.
Think about when your map app reroutes you around a traffic jam, or a digital assistant answers a super complex question. In those moments, you're interacting with the brain of this organism, machine learning. Rather than explicitly programming rigid, line-by-line rules, we feed massive data sets into models. This allows the machine to learn, adapt, and make remarkably accurate predictions in the wild using statistical techniques. It's all about creating a dynamic knowledge base that lets systems iterate and improve with minimal human intervention. It's pretty amazing.
Now, what's really interesting about this is that a brain needs to communicate, right? Natural language processing, or NLP, bridges the gap between human speech and machine understanding. When predictive typing suggests your next word, or automated customer service resolves a complaint through voice commands, well, that's NLP at work. It translates our unstructured human language into a format the digital organism can actually process, respond to, and learn from. It does all the heavy lifting for things like text-to-speech and speech-to-text.
Moving right along to Section 3, the senses, immersive experiences. Just as a living organism perceives its environment, we use immersive tech to interact with digital spaces in ways that stimulate us to visualize, feel, and react. We're talking about virtual reality, which completely overrides our physical environment, fully immersing us in a synthetic, 3D computer-generated situation. And then contrast that with augmented reality, or AR, which simply superimposes digital perceptual layers onto our existing physical reality.
And this brilliantly illustrates the difference. The applications represent two entirely different ways of experiencing data. A VR headset blocks out the real world entirely to plunge a user into a hyper-realistic flight simulator, a medical training environment, or a fully realized gaming universe. Conversely, a location-based AR app turns your smartphone into a digital viewfinder, floating reviews or navigation data right over the physical store aisles you're actively walking through. One takes you somewhere entirely new, the other enriches the very world you're currently standing in.
Next up, Section 4, the body. Advanced robotics.
Robotics is the interdisciplinary fusion giving our digital brain a physical form. Historically, robots were relegated to repetitive, boring factory lines. But today's advanced robotics are driven by the intricate sensors and AI models we just talked about. This evolution allows programmable machines to dynamically react to unpredictable environments and carry out highly complex or stressful tasks with extreme precision.
Consider the explorer species of our digital body. NASA's Mars exploration rovers, for example, are built for scientific data gathering in environments so hostile that a human presence is just impossible. They act as our physical avatars millions of miles away in space, feeding vital data right back to the organism's brain.
Now, contrast that rugged, wheeled rover with the humanoid. Robots like Sophia leverage AI and real-time visual data processing to read and actually mimic human facial expressions,
allowing them to interact with us in a uniquely familiar, human-like way. So from autonomous drones managing disasters from above to humanoids interacting with us face-to-face, the digital body is rapidly evolving and specializing.
Which brings us to Section 5, the lifeblood big data.
Every single time you send a text or walk past a cell tower, you contribute to a colossal flow of information. Get this, 2.5 quintillion bytes of data are created daily. That is an absolutely staggering amount of information. This volume is so huge that traditional databases have completely failed. We've had to invent entirely new architectures, relying on massive cloud computing networks, delivering infrastructure platforms and software as a service, along with distributed grid computing just to store, process, and pump this lifeblood through the system.
Let's move to and see how this builds out. Navigating this massive ecosystem requires understanding what actually makes data big. We define this complexity through 5 distinct characteristics known as the 5 Vs. It starts with volume, the sheer unmanageable size of the dataset. Then there's velocity, the exponential rate it's generated. Then comes variety, which is a messy mix of structured spreadsheets and unstructured data, like social media posts and images. But honestly, none of that matters without veracity. If the data is noisy, inconsistent, or biased, the organism essentially gets sick. If we can ensure veracity, we achieve the final V, value. By successfully mining this data, we can extract hidden patterns that yield massive business and scientific utility.
And finally, Section 6, the nervous system, IoT. So the crucial point is that for a long time, our smart devices worked in complete isolation. The Internet of Things changes that entirely. By connecting embedded hardware and software across everyday devices, I'm talking your microwave, your AC, door locks, security cameras, we create a collaborative, intelligent network that assists each other in real time. It acts exactly like a nervous system, sending impulses and data across a unified network.
But let's be real, managing dozens of disparate apps for dozens of individual devices simply isn't scalable. The Web of Things takes IoT a step further by utilizing existing web services to connect the physical world through a single, unified interface. Supported by incredibly secure, decentralized ledgers like blockchain technology to protect all this interconnected data, the web itself becomes the central dashboard. This is the infrastructure paving the way for truly integrated smart homes, smart offices, and eventually the whole shebang, entire smart cities.
So what does this all mean? We've toured the anatomy of the digital organism. Its AI brain, immersive senses, robotic body, big data lifeblood, and IoT nervous system. But I want to leave you with a provocative thought. How are your digital activities contributing to the generation of big data? Because every click, every voice command, and every location ping feeds this growing entity. You aren't just observing this digital organism, you are an active, vital part of its evolution. Thanks for joining me on this explainer, and keep questioning the technology around you.